Going to talk about computing hardware. We're going to look at some operating systems. We're going to look at a little library I made. I've been making an app. There's different ways to configure it based on how much hardware the user has. I want to set the defaults appropriately so the app puts its best foot forward so that people on Raspberry Pis and 15-year-old computers, classic computers, it scaled down to run well. But then people with AI rigs or gaming setups or ThinkPads with 96 gigabytes of RAM, they get a high-end experience showing what the app can do. I wanted something which could give me a rough feel for the user's hardware so I could set the defaults sensibly, and I looked for anything and I couldn't find it. And I looked into my repo and was like, well, my app's not really a hardware app. Why have I got all this hardware detection stuff just to set some sensible defaults? So I decided to rip out the hardware detection code and make it into a library, and that's called Caste, which is hardware t-shirt sizes. I say here, one size does not fit all, but 3 sizes give workable defaults to most. For most of human history, clothing was made bespoke. Modern industrial militaries introduced mass-produced clothing sizes, especially during World War II, when the US Army Quartermaster Corps dressed over 15 million servicemen using just 3 height categories: short, regular, and long. These spread to the civilian world. In some of these agile development methodologies, they size tickets by small, medium, and large, that kind of thing. Caste is a deliberately simple, opinionated hardware classification library. It inspects a user's machine and assigns into a small practical category. It's provided as a C++ library, a Python module, and a standalone executable suitable for shell scripts, build systems, and continuous integration. Modern applications increasingly adapt their behavior based on available hardware. AI, inference, video processing, rendering, simulation, and even UI effects often benefit from different algorithms or defaults at different performance levels. And games, of course. The challenge is choosing sensible defaults before the user touches the settings menu. Research constantly shows that users form judgments about software very quickly. Most users never change the default setting. This means defaults matter more than documentation. Your applications often launch with no idea whether they're running on a microcomputer, like Raspberry Pi, an aging laptop, a mid-range consumer PC, or a high-end workstation. If defaults are tuned only for the developer's machine, the result is predictable: sluggish experiences on low-end hardware, wasted capability on high-end systems, unnecessary user frustration. Caste exists to close that gap. So if your app looks crap, users aren't going to give it the time of day. If they turn it on and it's really sluggish on their low-powered machine, or it doesn't do much on their high-powered machine, they're not going to sit around reading the documentation, changing the settings. They're just going to leave for something else. Caste exists to set your defaults sensibly. Also, inclusive by design. There's a long tail of users running less powerful hardware than developers. When applications implicitly assume modern high-end machines, they unintentionally exclude users in lower income regions, users extending the life of older devices, schools, libraries, and shared computers, embedded and low-power systems. Scaling behavior by hardware capability makes software more inclusive without penalizing performance where it is available. Developers are pretty bad at this. A developer will go to their employer, I want a ThinkPad with 96 gigabytes of RAM, or I want a Mac with 24 gigabytes of RAM, or whatever. The employer will usually want to unblock them and get them to work fast. And in the past, it wasn't too bad, maybe, because, under the old-fashioned timetables, if somebody was building something for 3 years, by the end of it, maybe the users might have caught up with the developer's machine, but not today, where you produce apps quickly and put them out. Your first world developer machine, if you only test on that, then you give users a woeful experience. The environmental motivation. Electronic waste is a growing global problem. Extending the usable life of existing hardware, rather than forcing upgrades through poor defaults, is increasingly recognised as one of the most effective ways to reduce environmental impact. Software that adapts gracefully to older machines helps keep them useful longer. Hardware detection code is low-level, platform-specific, verbose, usually written once and forgotten. Embedding it directly into application logic pollutes code bases for minimal long-term value. Caste isolates that complexity into a small reusable library so your application code can stay focused on what it actually does. Instead of me writing hardware detection and you writing hardware detection and every Tom, Dick and Harry writing hardware detection, let's just collaborate on one hardware detection library. T-shirts are like small, medium, large, extra large. I've gone for mini, which is a microcomputers, embedded systems, classic PCs. User, so if you go to the nearest supermarket or PC shop and buy a consumer level machine, that would be like user, a solid consumer level machine. And then developer is a high-end personal computer. They're the 3 main use cases. If you let your app adapt to these 3 cases, then you'll give pretty much all users a good experience. You can let them tweak it as much as you want, but they give them a good default experience. But I've also got 2 extra classes for unusually powerful systems. So workstation, professional content creation or high-end gaming machines, and a rig is like your dedicated server or specialized compute system. AI inference training, Bitcoin mining, those kind of machines. I'm trying to make it work on everything so you don't have to. That's the idea. Let's show you on this machine. Nothing up my sleeve. I'm going to check out Caste. CD into Caste. And we're going to make. So it made Caste and it ran the test. So I'm going to go into build. And I'm going to run it. And it's going to categorize this machine as a developer machine. Why has it done that? Because it's got discrete GPU, but it applied a RAM cap to stop it getting in the next level after developer. So after developer will be workstation, and it didn't have enough RAM to call itself a workstation. Another way, we can look at hardware facts, and we can see that it has 64 gigabytes of RAM, 6 processor cores, 12 logical threads. It has a discrete video card, has been NVIDIA one. It's got 6 gigabytes of video RAM. It's got a discrete GPU. It isn't Apple Silicon, it isn't Intel Arc, and it's decided to developer. So there's a C++ library, and then as I said before, there's also a Python library. You can get either through here. Is it that? There we go. So it's found the PyProject file. It has built Caste and it's made a wheel and it's built it. So for Python, you don't need to check it out. We're gonna instead do a more normal and make a VM. Pip install Caste. Collecting Caste. Right. So import Caste. So we've got some methods. We're gonna do detect Caste. You see it's developer. And then we've got a reason, so that's the thing, that's the Caste, and that's the reason. We can also detect Caste word. You just want the left side. If you want the full information, then you've got the hardware facts. So you can import Caste, and then it's true, it has. That's all it does. That's all you need. All you need to know, really, is that. So you say, in your program, you can go, hardware tier or something. The Caste is in. And, if hardware tier developer do something. You can do different things based on what hardware tier they're in. You set your defaults differently. That's the whole concept. So when setting your defaults, you just choose different defaults for 3, maybe 5 castes. You could say if hardware tier in developer, user, workstation. If it's in those, then do something else. The main thing is you don't have to care anything about the user's hardware. You just import Caste and it will do it for you. It has the C++ code underneath because on some platforms, Python can't access the exact details you need. So we need C++, and it's fast. So that's my idea.